This is a UEFI implementation for a RISC-V virtual platform. Glancing at the device handle tree, it's challenging to really understand what the platform is made of. There are a number of drivers, but these, like the VirtIO, Serial Console, and PCI Express root, don't follow the UEFI driver model. From an engineering perspective, such an implementation consists of drivers that create device handles in their entry point function and are build-time configured using macros, PCDs, and libraries. For example, the Serial Console is provided by Serial Dixie, which uses the serial portlib to abstract hardware and supports only a single device. Writing drivers for typical, non-discoverable devices in modern system-on-a-chip designs is, well, complicated. You need to figure out how to describe the devices and their dependencies. Consider an onboard video device consisting of an LCD controller, video decoder, and multiple outputs, such as an HDMI encoder on an I2C bus. And then there are assorted clocks, pin muxes, reset signals, and power regulators to contend with. It can get hairy, and you're looking at a monolithic beast of a driver or at figuring out your own layering. And what if you need to target several board or chip variants with different wiring with a presented set of controllers? Enter FdtBusPkg, building on top of existing technology investments by using device tree for device discovery and embracing the UEFI driver model. The device handler tree here reflects the real device topology. The Serial Console is clearly a UART. You can see the NOR flash used for variable services, the PCI Express route, VirtIO transports, as well as other devices that are present but unused by this implementation, such as the real-time clock. We can learn more about this RTC with a DT-Info tool, which lists the memory map registers and the driver compatibility string. We can even read the register using the DT-Reg tool. The DT-Prop tool can dump arbitrary device properties, in this case, listing apertures for a PCI Express route. The tools can be used to debug and to learn more about the system both as a firmware or OS engineer. For example, it is easy to find out what instructions that the CPU supports. The new DTIO protocol makes it trivial to build robust, driver model compliant reusable code, like the PCI Express Rubridge driver seen here. Let's tear down the entire PCI Express stack with all the drivers, including the bus driver, and reconnect it again. These same components scale without any changes and will work on systems that include 1 or 100 root complexes. The DTIO protocol radically simplifies development, abstracting device property access, register I/O, DMA buffer handling, and device enumeration. Learn more by visiting the project page and by reading through the available docs.